once we've found our x-intercepts, found our zeros, those tell us, right, where the function hits the x-axis. And what we need to do is, so for each x-intercept, aka the zeros, what we need to do is clarify. We need to know if the function, so there's two things that can happen. The function as an x-intercept can either cross through the axis and sort of travel from the positive to the negative side, or vice versa. That's, I think, for the most part, kind of what we think of as an x-intercept. The other thing that can happen that's maybe a little bit less obvious is you could have something like a touch point, where you actually sort of go up and touch the axis and then sort of turn back the direction you came from. So we need to know if the function is crossing the x-axis or doing a touch and turn. So we need to know if each of these points is a cross point or a touch point. So crossing the x-axis, we'll do just a little super tiny sketch. Crossing the axis would be like any of these values that we had before, right? These are all crossing points. You're crossing from negative to positive, positive to negative, and then negative to positive. Touch point, on the other hand, is still an x-intercept, but what's happening is you're coming down, you're just touching the axis, and then you're going back up. So these still count as x-intercepts. These are just going to be touch points instead of these, which are all crossing. So this makes a big difference, right? If we're trying to make a sketch, knowing that we have an x-intercept doesn't necessarily tell us by itself which of these two things is happening. So that gets us into the idea of multiplicity of the zeros, multiplicity of the x-intercepts. Roughly, this means how many times are each of these like x solutions, or each of these x values showing up as intercepts. So multiplicity So this means how many times is each x-intercept a solution. Now that's maybe a little bit of a weird thing to say, but so let's, as always, let's try to illustrate this with an example. Let's actually go back to one of the ones that we just did in the last video. We're talking about the x-intercepts. So we started with, right, f of x. Our f of x in that case was x to the 4 minus 5x cubed plus 6x squared, right? We set it equal to 0, and then it factored into, we'll kind of jump right to the good stuff, x squared, and then it was x minus 2, x minus 3. And so what happened here, right, is we ended up with, we said this sort of x squared equals 0. And to a certain extent, I sort of said at the time, somewhat shortly, this would really be x times x equals 0. And so you can kind of make the case that individually for each of these x's, you're sort of getting a 0 that shows up once, which means in some sense x equals 0 is showing up as a solution twice. If you have this individual x squared, in theory there's two x's here that are sort of getting associated with this x equals 0 solution. So this would be for us multiplicity 2. So that shows up as a solution twice. The x minus 2 here, right, gives us x equals 2. The x minus 3 gives us x equals 3. These are each only showing up once as a solution. So this would be multiplicity 1, and x equals 3 would have multiplicity 1. So the idea here is if your x equals 0 in this case is sort of coming from an x squared, it's sort of showing up as a solution for two individual x's. In some sense, if we have a degree 4, we kind of need to account for like 4 x's as far as our solutions go. So two of them give us these solutions x equals 0, one of them gives us x equals 2, one of them gives us x equals 3. So what do these multiplicities tell us about being a touch point or a cross point? So our rule is for x-intercepts / zeros, we're kind of calling them both. So if your multiplicity is odd, so for us, typically, not always, but typically that's going to mean 1, right? If it's showing up once, or in theory 3 or 5 times, as you get, you'd obviously need sort of a much bigger polynomial for that to happen. But certainly if it's showing up only once as a unique solution just for one of our things, like the 2 and the 3 here, that means the x-intercept is going to be a cross point. So that means for us, back here, x equals 2, and x equals 3 are both going to be crossing values. So x-intercepts where the graph is actually crossing from positive to negative or vice versa. Again, this is definitely going to make a difference when we try to make our sketches. If the multiplicity is even, well, you can probably guess, I'm sure you're yelling at your screen, that if the multiplicity is even, that must be a touch point. And that's correct. The x-intercept is a touch and turn touch point. So if your multiplicity is even, again, probably that means for us that it's going to be 2. In theory, it could be 4 or 6 or 8 if we have just like a very, very big example, a very, very big function. In this case, the zeros here, multiplicity 2. This is going to be a touch at x equals 0. So that's showing up twice as a solution. I know this is a little bit of a strange thing. Let me show you another example. We'll sort of run through this a little bit more quickly for a new function that's been sort of pre-factored. I think if we look at one that's been pre-factored a little bit, it's going to make this a little bit more clear. So this is 3.2 multiplicity continued. So this is example number 2. So let's take a new function. Let's do h. Let's say h is 3 times x. Let's say it's x minus 4 quantity squared. Let's say it's, I don't know, x plus 2, like that. So let's say this is something we have that's essentially pre-factored. We're going to see some graphs like this. It definitely saves us a little bit of time, so that's always nice when we have that set up. Saves us from having to do the factoring ourselves, and it allows us to do some more interesting graphs where if we sort of expanded this out, we just might not have the tools to sort of factor it on our own. So find the x-intercepts, okay? So that means setting this equal to 0. And so what's going to happen here then is you're going to get 3x equals 0. That's just a single x, right? So for us, that's going to mean by itself, if we do like a division by 3, that 3 is kind of trivial. So that just gets us x equals 0. Let's hold off on all the multiplicity stuff until we're at the very end. in theory, right? That looks like it's just showing up once, but let's just make sure we're not getting any other x equals 0's solutions. The one in the middle, right? This is the one that maybe is a little bit new, x minus 4 squared. So this means x minus 4 times x minus 4. So that means technically what we're getting are two individual x minus 4s, and you're probably going to be able to guess what this means as far as our multiplicity goes, right? If this quantity is squared, that means I'm going to get x equals 4 as a solution twice. Again, we'll kind of wait to the end. This is a little bit unnecessary, but just for completeness sake, just to not get ahead of ourselves, let's wait till we get all these solutions in, and we'll just sort of count up if we have any repeats. Last but not least, excuse me, x plus 2 equals 0, so that means that x is going to equal negative 2. I didn't say it yet, but in theory, the degree of this polynomial, this would be x, this would be x squared, this would be another x, so x and x squared and x is 4 x's altogether, would be x to the 4. So our degree here is 4, which means we need to sort of account for 4 potential x-intercepts, and we did. So 0, 4, and 4 twice, and then negative 2. So what's happening here, right, is x equals 0 is multiplicity 1. X equals 4, right, showing up twice. That's going to be multiplicity 2. And x equals negative 2 shows up once, is going to be multiplicity 1. So our multiplicities should add up. If we add up all of our multiplicities, we should get back to the degree of the original polynomial. We should, in theory, end up with, right, solutions here for each of our x's. Maybe I shouldn't quite say that if you had an example that didn't factor all the way and maybe some of your solutions were imaginary numbers, then okay, that's not entirely going to be true. But to a certain extent, for the graphs we're working with, what we're going to see in here, probably that's going to be true. And that's the basics of it. So that's multiplicity and sort of using multiplicity to figure out if you have a cross or a touch. We should say, right, where the multiplicity is 1, that's going to be a cross, right, because it's odd. Where the multiplicity is 2, that's going to be a touch. So this is a cross, a touch, and then a cross. And there we go.